We can also calculate the area of a sector. So the area of this sector here, we need to know what fraction of the whole circle we have. So in this case, x over 360. 360 is the whole circle, x is the angle within our sector. Then we'll just times that by the area of the full circle. So let's say A for area. Obviously, you can put this in terms of the equation for the area of a full circle. So this would become x over 360 times by pi r squared. And this is the area of a sector. You can also calculate the perimeter of a sector. So for example, starting at this point, along this bit, round the arc, and then back to the point we started at, you'll notice this was a radius, this was a radius, and then we already know how to calculate the arc length. So putting it all together, it's going to be x over 360 times by whatever formula you want to use for the circumference. So for example, 2 pi r or pi d. So let's say c for circumference. Plus, remember we had a radius and another radius, so plus 2r. And again, this equals the perimeter of a sector. You can, of course, put this in terms of the actual equation for the circumference. So you could have either x over 360 times by 2 pi r, if you want it in terms of the radius. That makes it nice and easy because then the whole equation is in terms of the radius. Or if you want to, you could have x over 360 times by pi d plus 2r still. So as you could turn this into the diameter as well. You can simplify it down quite a lot, but we'll leave it in terms of this for now. A segment can be considered the end of a sector. You'll notice here, if we were to shade this whole area, that would be a sector. So, therefore, we can still calculate the perimeter of a segment. That is made up of an arc length, which we know is x over 360 times by the circumference, plus this length here. Now, that's not as easy to work out. So this is what we call a chord, and you'll need the chord length. You might be given it. If you're not given it, you could use the cosine rule. You could use the cosine rule and work it out. So you'll get a squared equals b squared plus c squared minus 2bc, and then cos of the angle A. So it's x over 360 times the circumference plus the chord length. Again, you may be given that at times, or you may be expected to find it. We can, of course, also work out the area. So remember, this was for the perimeter. So this was for the perimeter. We can also work out the area of a segment. So to do that, we've got effectively a sector and then a triangle taken away from it. So it's the area of a sector that corresponds to it. Take away the area of a triangle. So how can we put this in terms of a circle? Well, it's going to be x over 360 times by pi r squared, because that's the area of a sector. Take away the area of this triangle, but remember, B and C will both be r, because they're both radii. So take away a half r squared sine of A, the formula for the area of a triangle.